Good morning, Year 4, and welcome to your maths lesson for Wednesday, the 10th of February. We're going to be doing our fourth and final lesson on equivalent fractions today, and we will be doing a lot more work on fractions, but this is the final one on equivalent fractions for the time being. So, to begin with, we're going to warm up as we always do, and put some more Roman numerals for you today. So if you can pause the screen here in a second and then have a go at looking at which numbers do these Roman numerals relate to. So we've got some that we had in yesterday's lesson. So we've got the x, excuse me, is 10, and the I is 1, V is 5. So we've done those already. And can I remind you here, this one here, we've got 1 before 5, which is 4, isn't it? That's worth 4, so 1 less than 5 is 4. And then this next one down here, we've got a 1 before an x, and that's 1 before x is worth 9, isn't it? And then there's some new ones added along the top there. So if you can pause here and have a go and see if you can work out which numbers these Roman numerals relate to, and then we'll come back together in a second. Okay, so moving on to the answers. Again, you can pause these here and check what answers you've got. I love that the fact that number 38 is one of the smallest numbers up there, and yet it's got loads and loads of letters. Look, just because that's just how it is. It's got x and x and x, which is 10 and 10 and 10, so it's 30. And then it's got the 5 and then 3 ones, which makes the 8. So there's lots and lots of letters to represent that one. Okay. Moving on to the main part of the lesson, if you can have a look at these. So what I would like you to do is I'd like you to have a go at looking at A and B, and I'd like you to see if you can work out how many sections of this one. There are 12 equal pieces in this one. It's quite hard to count, so I'll tell you there are 12 equal pieces. How many of those pieces do I need to colour in to make it equivalent to that one? So you can have a think about that in a second. And then down here, you don't need to draw these out, but you can write the fractions down and work out which two fractions are equivalent to each other. Okay, so pause here and have a try at that. Okay, moving on. I've written these out already, so you don't have to watch me do it again. So the first one is 1/4. So there are 4 equal pieces, one of them shaded in. And then on the bottom one, as I said, there were 12 equal pieces, and I had to shade 3 of them in. And you can see that that is equivalent from the pictures there. And I actually knew that I had to do 3 before I started colouring them, because I know that 4 times 3 is 12. So I know if I'm multiplying by 3, and I want an equivalent fraction, I've multiplied the bottom by 3. I've also got to multiply the top by 3, and 1 times 3 is 3. So I knew I had to do 3. And then moving on down here, we've got 4 equal pieces, 2 shaded in. So that's A, 2/4. 6 equal pieces, 2 shaded in, 2/6, and then 12 equal pieces and 6 shaded in. That is 6/12. And you can see that A and C are equivalent fractions because you can see that they have got the same amount shaded in. You can also see that 2 times 3 is 6 and 4 times 3 is 12. So those two, that one, the top one and the bottom one, are equivalent fractions because the bottom and the top numbers, the denominator and the numerators, have both been multiplied by 3. So watch again, 2 times 3 is 6 and 4 times 3 is 12. And you can see that doesn't work with this one here, does it? Because if you can see, this one hasn't been multiplied by anything because the numerator, is the same on the top of both of them, and then they've got different denominators, so they can't be equal. If I change this to a 3, then it would be an equal equivalent fraction, but it's not a 3, it's a 2. So A and C are equivalent, and B, sorry, you're not going to win today. Right, moving on. I would like you to just pause for a second and write down the fractions that are represented in the pictures up the top for me, please. Okay, and then if we have a look at them, we've got 1/3 up there, so 3 equal pieces, 1 coloured in. This one we've got 6 equal pieces and 2 coloured in. And the bottom one we've got 4 equal pieces, 12 equal pieces and 4 coloured in. Okay, so and then we can look down here, we can see how we got to those. if we didn't have the diagrams to count the pieces, we could actually do this by multiplying the numerator and the denominator by the same number. So here we've done 1 times 2 is 2, and 3 times 2 is 6, and we've multiplied by 2 both times because we have to do the same to the top as we do to the bottom. And then to get the next one, we just multiplied by 2 again. We don't have to multiply by 2. We could have multiplied this by 3, the top one by 3 and the bottom one by 3, or 4 or 5 or whatever number we wanted. But I've gone for 2 again because that's nice and straightforward. So 2 times 2 is 4. 6 times 2 is 12. And then if I want to follow my pattern, still multiplying by 2, just pause here for a second and see if you can work out what the next one will be. If we're multiplying by 2 again, 4 times 2 is what? Goes on the top for the numerator, and 12 times 2 is what? That goes on the bottom for the denominator. Okay, so just pause here and have a little go at that. Okay, so let's pop the answer in. 4 times 2 is 8, so let's come out in the wrong place. There we go. No. Doesn't want to behave today. Let's try that again. 8. So 4 times 2 is 8, so the numerator is going to be 8. And 12 times 2 is 24. So 24 is going to go on the bottom there. And I just want to make sure that you understand you don't have to put you don't have to multiply by 2 every time. You don't have to. I could have multiplied that by 3 if I wanted to. As long as I do the same on the top and the bottom, I could have done times 2, then times 3, then times 2 again, and then times 5, or whatever I wanted, as long as I do the top and the bottom by the same number. Okay, let's move on to this one then. So challenge here, I would like you to pause and I would like you to work out which one is the odd one out. Now, a little tip for this, the way that I worked this out really quickly is I looked at all the denominators, so that's the number on the bottom, and I could spot a times table that all of those numbers were in, and that gave me a really big, well, all of them except one, and that gave me a really big hint as to which one might be the odd one out. So have a little look, see if you can work out the odd one. Off you go. Okay, so as I said to you at the beginning for a little hint, the first thing I did was notice that these numbers 24, 32, 16, 40 and 8, because I know my multiplication tables, I thought, oh, do you know what, I think they're all in the 8 times table, so, and 9's not. So straight away, I was a bit suspicious about that cheeky number 9 in there. And if we look at 1/8, just get my pen. If we look at 1/8 as a fraction, I want to link it to each one and see what happens. So 1, if I look at the one next to it, 1 times what makes 5? Well, 1 times 5 makes 5. So 1 times 5 makes 5. 8 times 5 makes 40. So that is definitely an equivalent fraction because we can times each of those by 5 and top and bottom by 5, and that one is correct. Then if I look at this one, and I'm going to compare it to the 1/8 again because it's just easier to compare it to 1/8 because it's easy to multiply. So 1 times what makes 2? Well, 1 times 2 makes 2. So I'm going to write times 2 there to remind me. 1 times 2 is 2. And then if this one's an equivalent fraction, then 8 times 2 should be 16. And is 8 times 2 16? Yes, it is. So that is also an equivalent fraction. Then I'm going to go back to my 1/8 again because they're nice and easy to use, as I said. So my first one, I'm going to look at this one now, 4/32. 1 times 4 is 4. Okay, so I'll write times 4. Oh. And if it's an equivalent fraction, then 8 times 4 should be 32. And I know that 8 times 4 is 32. So that one is also an equivalent fraction. And then looking at this one, 1 times 3, right, times 3 there. 1 times 3 is 3, and 8 times 3 is 24. So that one is also an equivalent fraction. And I didn't need to draw anything for that. And if you did draw something for that, that's absolutely fine. Obviously, once we get up to like 5/40, it's quite tricky, isn't it, to draw a shape with 40 equal pieces and then colour in 5, and then that gets a bit tricky. And then if we have a look at this one, which was the one that I suspected might be our cheeky little imposter, 1 times 2 is 2. So we've done times by 2. 1 times 2 is 2. But 8 times 2 is not 9, is it? 8 times 2 is 16. So that one is not correct because it's times 2 on the top, but not on the bottom. So that one there is our one that is the odd one out. It says circle the odd one out. So let's do that. So that's the odd one out, okay? And that's because 1 times 2 is 2, but 8 times 2 is not 9. 8 times 2 is 16. So that one is not an equivalent fraction. So well done if you worked that one out. And explaining your reasoning, you should have just said something like what I've talked through before. Okay, so you know that all of these are equivalent fractions because the denominator and the numerator can be have been multiplied by the same number, which is what we've got in our steps to success down here. But 2/9 isn't equivalent because 1 times 2 is 2, but 8 times 2 is not 9. So you should have explained in words something like that. Okay, moving on then, these are your challenges for today. So for silver, you're looking to find equivalent fractions for these shapes. We've got 3/4, and I've done a picture for you to represent that. So 3 out of 4 equal pieces are shaded. 2/5 here, 2 out of 5 coloured in, and 3/8 here. Now, what I would recommend is that you try and use the multiplying the top and bottom, the numerator and the denominator, by the same number. Just move myself out of the way so you can actually see the steps to success. So maybe do 3 times 2, and 3 times 2 is 6. So I'd put 6, not there. 3 times 2 is 6. So that goes on the bottom. And then 4 times 2 is 8. So I'm going to put 8 on the bottom. So that would be the first one. And then I can either do times 2 again if I want to, and times 2, or I might do 3 times 3 and say, right, 3 times 3 is 9, and 4 times 3 is 12. So I'm going to do that. So you can multiply it by whatever you want to do, okay? You can come back to that first fraction and multiply it by a different number. So we've multiplied it by 2. Now we could multiply it by 3 and multiply it by 4. Or you could multiply that one by 2 and then the next one by 2, whatever you want, and then the same for the others, okay? There are lots and lots of different equivalent fractions that you can find for those. And then, so pause here and have a try at that for silver. And then for the gold activity, match equivalent fractions. So the fraction that you've got is 2/3 here, and I've done a pictorial representation of that as well. And what I'd like you to do is to tell me which one of these fractions are equivalent and which ones are not. Okay, why not if they're not? So what do you need to do? For example, if you were doing this one here, write them next to each other in your book. And then you'd say, right, 2 times what makes 4? Well, 2 times 2 makes 4. Does 3 times 2 make 9, though? No, it doesn't. Therefore, that one is not an equivalent fraction, okay? And when it says, why aren't the others correct? Why is this one not correct? You would say, this one is not correct because 2 times 2 is 4, but 3 times 2 is not 9, so they're not equivalent, okay? And you do the same for the others there. Some are equivalent and some are not, so pause here and have a try at that. And then platinum today. Oh, my face is in the way again. It's a problem I have a lot in my life. Right, okay, so Igor is investigating equivalent fractions based on the shape below. Which equivalent fractions could he have found? Find 3 possibilities. Now, the first thing I recommend you do is to count up how many squares there are and how many are shaded in and get yourself a sort of basic fraction. And then you can work back from that, so you can make them smaller or bigger to find equivalent fractions. Okay, so if you have a try at that, and then pause it and have a try, and then in a minute I'll just move this, and there are a couple of examples there that you can check. They're not all the answers, they are some answers. Okay, so pause here and have a try at that. Okay, and then here are some answers that you might have put. So 12 32ths, because there are 32 pieces and 12 of them are shaded in. And then all I did to get the others was I actually halved them, because remember I said you can multiply or divide. So I've halved them, divided by 2, divided 32 by 2 and got 16, divided 12 by 2 and got 6, and then I divided it by 2 again. So I did 16 divided by 2 was 8, and 6 divided by 2 was 3. So those are some answers. You could do lots and lots of different answers. As long as you've multiplied the top and the bottom by the same number, all of your answers will be right if you've done those things. Okay, so well done if you had a go at Platinum. That's the end of your maths lesson for today. And I will be back tomorrow with some more fractions, but not equivalent fractions, and hopefully not a noisy dishwasher beeping in the background. Okay, so well done, and I will see you tomorrow.